to speak. I'm going to give a quick update on the Hartree Centre, sort of our activities. And I think first off, I'll start, as other speakers have, just explaining who we are. It's probably less likely you've heard of us than Argon and TAC, for example. So the Hartree Centre's based in the UK, up near Liverpool and Manchester. We're funded by UK Research and Innovation, who funds all the academic research in the UK. But our primary goal is maybe slightly different for most HPC centres. We're funded to help industry use this technology, and our mission is to drive the uptake of high-performance computing. Here we go. Okay, so I can't remember exactly where I was when I cut off, but I think I was saying that working with industry means we see work of many varying different scales, from SMEs taking their first steps into even modelling and simulation, let alone HPC, helping them understand CFD and finite element analysis and the like for their work, all the way up to the large and confident, established companies such as Rolls-Royce and Unilever, who want to use, large portions of the machine for their workloads. And it was good to hear that our solution is similar to the one taken up by TAC for the big jobs, which is schedule them directly after maintenance when they fit in a little bit easier. So to try and put that mission statement into some kind of concrete examples for people, our work with Rolls-Royce has been going on now for in excess of 6 years. And we work directly in their engineering source code, in their CFD and finite element models, updating the MPI, OpenMP implementations, and helping them port to new architectures such as GPUs, which have been popular in the presentations today. And over the course of these 6 years, current estimate is that we've sped their production software by 20%. And a lot of our philosophy is to work closely with the engineers and software developers at Rolls-Royce. So actually, the changes we propose and make in the repositories are accepted into the main branch of the software very, very rapidly. And we're transferring knowledge and expertise into those teams so they can maintain the software and do similar improvements without us even. Just because we work directly with companies, and the previous example with Rolls-Royce was a commercial interaction, so Rolls-Royce pay on a commercial contract for that kind of code modification. We also work, like most HPC centres, in an academic research area, but the research we engage in always has an eye to benefiting our industrial partners. A good example, which is just summarised on this slide, is a project called Dynamo. The motivation behind Dynamo is to reduce engine pollution, such as NOx and CO2. And I've included this example just to show that although we have an industry focus, we do collaborate with academic partners and provide access to the machines to universities. The primary work here is to run high fidelity combustion and CFD models of the engines. Use those models to generate surrogate or reduced order models, which can then be used as objective functions in the multi-objective optimizer, which is also running on our systems. It sort of combines the whole gamut of high fidelity, reduced order models, academic partners, large multinationals and SMEs, all using our systems and working with us to get the best use of those technologies. So a quick overview of our systems. I think it's fair to say we have a collection of lots of different architectures, as you can see here. Our main workhorse, called Scaffold Pike, is a full Quana system. That is a halfway split between Intel Skylake and Intel KNL, and that's running a Mellanox InfiniBand interconnect and a Lustre Fire system. Again, behind all of this, we have a central data store, similar to TAC, which has its benefits and has its downsides. But we also host a number of IBM data-centric platforms. So these are old now and moving towards decommissioning, but they're Power 8 with NVIDIA GPU. And we host one of the UK's tier 2 machines. We're hosting this one for Oxford. This is called Jade, and it's primarily focused on deep learning workloads and is DGX1 system. The currently upgrading this to J2 with some newer and larger hardware, and hope to have that online within the next few months actually, and available to UK academia to take advantage of. Motivated by questions from our industrial partners, as well as some of our academic ones, we started to explore quantum computing and putting in simulation environments for people to understand this new paradigm in computing and how they may be able to take advantage of it. And so we host Natos QLM, but we also run the Quest open source simulation software on Scaffold Pike as well. All of this is then combined with an on-site visual computing suite where we have the usual large wraparound screens and VR equipment to help people understand their data and see how they can extract useful information out of the models. So our work here is focused on getting ready for Exascale and helping the UK Met Office prepare for this new computer as well. Sergi's presentation at the Multi-Core 10 workshop hosted by NCAR should be available online soon, and it goes into a really good deep dive of both the Cyclone tool and what we've done here. Primarily, the Cyclone tool is a domain-specific compiler or DSL or code generator, whichever term you prefer, which parses an algorithm code written by the weather and climate scientists, and we can now generate a number of backends. Probably primarily of interest here is that we can generate SQL code as well as Cocos, and we support OpenCL and Fortran as well. And the aim here is to help these communities take advantage of the diverse and the heterogeneous architecture base that we're seeing in recent years. So my final slide, I just wanted to introduce the Excalibur program. We're participating both with UKAEA, which is the Nuclear Fusion Research Atomic Energy Authority in the UK, as well as the Met Office. This is funded software and hardware development in the UK to prepare for exascale computing challenges. And projects are themed by priority use cases such as fusion energy or weather and climate or large scale engineering. And really we are trying to develop new libraries and capabilities that will let these communities use exascale computing when they become available in the UK. So that's all from me. Sorry for the connection issues, but I can stay around to answer questions for a little while yet.